says 40 years of experimenting with magnet motors that he hasn't found anything much better to do to charge a 12-volt battery. To charge that.
I'm not going to talk what he can and can't do. I know that Edwin Gray ran a 300 horse motor on this energy, and he did not need to plug it in the wall. I know that Stan Myers split water, and I know that Herman Anderson split water. These guys all claim. I never witnessed these guys, but I've seen incredible evidence. I know they didn't do it with what we pull out of the electrical wall sockets or out of batteries. I've tried everything. I've met a lot of people that try that. You don't get, 5,000 liters a minute on 10 watts.
But maybe Bedini is saying that because it's once the battery is charged, it's something that everybody can use and understand.
Well, the thing is, I can say this is different. This is different energy. This energy to me is static, like static electricity. When I feel this, watch it, it's different. It acts different, it sparks different, it handles different. What a capacitor, what a battery does is allows you to convert it. Once you get it into a capacitor, you can store this energy up, the batteries or the capacitors charge, and then you can extract out of it. You can take the energy out and convert it. It's convertible. It's not, and it is usable in this form too, but you got to build devices for it. I mean, like the light bulb light's great. You can make heating elements of this and different things, but it's different. Yeah.
Can you put this into the grid?
Yeah, you could. That's what Tesla wanted to do. He wanted to build a grid that you could transmit the scalar wave through and collect it at the ends. But if I put this in the grid right now, our grid would collapse because it's not. You can't mix them. You can't mix them.
They're two different forms.
They're two different forms of energy. They're completely different. It's like you don't put DC and AC in the same circuit, on the same wires.
What would you suggest to use this for?
Well, what I've been trying to scream and yell for the last 5 years is we need to study what this is. Because if we don't study what it is and don't know what it can do, we can't build devices for what it can be done. We have seen the evidence of other inventors which we will not talk about or have died that had devices that would run large light bulbs, and run large homes and heat their homes, power their cars. Some claim fly UFOs and all that stuff. We have not, as a society, understood this, what it is and how it works. So I'm saying, instead of claiming I can build a device right now, I'm saying we need to study this. We need to learn what this can do, how to handle it, how to wire for it, how to design for it, how to understand what we're doing before we try to build a UFO and fly off to Mars. Let's try to understand what's going on, build a simple device that can charge a battery, heat our home, power a car, instead of jumping down the road, trying to think, I'll just skip university 101, I'll just go to graduate class. I'll take the last class that he took to get his doctorate.
Why not?
It doesn't work that way. You have to take AEPC.
A Warden Cliff Tower.
Pardon me?
Why not build a Warden Cliff Tower?
Well, I'm not saying that we need to do that either. We need to stay with Tesla did and the devices. These devices often came after Wardenclyffe, and he's left us and knows how to do this. He had his hands tied behind his back in a lot of ways that we don't. We have fancy meters and computers. Number two, we've got the internet, we can communicate. Number three is we have semiconductors, we can pulse and switch and make oscillators and stuff that he did not have. And so we need to understand this to build devices that are not spark-gapped hairpins. We need to understand, and I'm not going to get into it again, I build devices, as Bob Boyce has built toroids that pulse and make the scalar wave and do a similar thing. But I wanted to show the basic simple. This is simple. I mean, this is about as simple of a circuit one could build. Yet I don't see any other on the planet. I've looked. This is the only one so far that I can find. And it's in every lecture he gave.
So this will be a good device to make, let's say, like an electric car or something like that?
No, this is not going to make an electric car. This is to study how it works. And if you look at, study Avro-Romanko patents. This is a big topic, again. This is an Avro-Romanko diode plug. This is just two diodes made into a letter Y, one up, one down. You touch it to a device such as a scalar wave generator, single wire circuit, it will pick up energy and you can actually measure it or arc across the ends. What I do is if you put it on every single Electrical switch, MOSFETs, went on and off, click, 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 completing a circuit. If you put this shunt, the reverse diode, like Bendini says, like his circuit, you can send that energy to a charging battery. Now your circuit stays cold, it doesn't get hot. My MOSFET's on a run on, just say, a pulsing circuit, a simple PWM. When it pulses, the MOSFETs get hot. You put a recovery diode on the circuit, they stay cold. Charge the battery. Electric motor running, ironically, is a pulsing circuit with a brush of DC ones, not AC. And what happens is you can put a recovery diodes on these motors, and you can collect this energy instead of sending it to ground, you can actually collect it. Every time that the PWM on the car, electric car, pulses 25,000 times a minute, 25 kilohertz, every pulse has a back EMF or a scalar spike coming off of it. And you see it on the oscilloscope, there's a big spike come up, you see these big chops. You can collect that with a recovery diode, put the diode backwards to the normal way, and send that to a charging battery circuit. You can charge off that wasted energy. And that's basically what we have going on over here. I mean, I've built lots of these and studied this device. And the Bendini motor is doing this. He's folding the electromagnetic field back on itself and collapsing together, making a zero vector wave and sending that to the charging battery. The charging battery's inductance breaks that apart and makes electricity charge itself. Any other questions?
Then get the questions.
What's that?
Let's hear the rest of your presentation, then get questions later.
Well, it's a good. I want to run this quietly in the back room where it's dark, because we'll see way more effects that we can of that. So I was wondering if you had questions regarding.
One more question.
Yes.
Is it possible that somebody will put that book in print?
I have no idea. I don't have the rights to the book. The book was actually published in the. It's actually all in Serbian. I can't even tell where it's from. It's from. It says Belgrade Museum, but it doesn't even have an ISBN number, and it was published in 1999. Pardon? This book's in English. This other one is in mixed Serbian English. They're out there. I've got it on eBay.
In Belgrade. That's
Yeah.
Romania. That's
Romania. This is book published by the museum in Romania. Okay. So I guess we'll move to the back room now. Yeah?
So, Otis Carr.
Which car?
Otis Carr.
Yes?
Not the elevator company either.
Yeah.
But Otis Carr was a student of Tulsa, near New York City, where we're both from. And Tulsa was teaching Carr to the
He taught lots of people. He was open to talking to just about anybody that would listen to him.
right.
You know? I mean, this guy is really, if you think about what he did, he arrived here penniless and poor. Within 10 years, he was a multi-millionaire in the 1800s. If you think about that, that's like Bill Gates now.
Yeah.
Would you turn your back upon what you built? Would Bill Gates buy Apple because it's better? No. You stick with what you know. Tesla came across and said in 1907 in New York at the Niagara Falls convention, he said, "I wish I had never released alternating current to the world because it's obsolete and crazy. It's inferior by far." He said, "I wish I had learned about the scalar wave, or the radiant energy, he called it, device, and went right to that because you can do so much more with it."